So suppose we have a radical that looks something like this. Say we have 72 x to the fifth, y to the third, and we're looking to simplify it by pulling out any perfect squares. So we're going to look at each of these things separately. We have the number, we have the x term, we have the y term. So over here, we're going to draw another radical that will contain all the perfect squares. And that's going to be multiplied by another radical that will contain everything that's left after we factor out the perfect squares. So 72, for example, is equal to the product of 36 and 2. 36 goes on this side because it's a perfect square. And 2 goes on this side because it's what's left over. Then we look at the x to the fifth. Well, in order for it to be a perfect square, it has to have an even exponent. So since the exponent is 5, we're going to mark it down to the next even number, which is 4. And that means we have an x to the first left over here. The y, it's also an odd exponent, so we have to go down to y to the second, which leads again to the first, but this time y to the first. Now what we have over here is a perfect square, because anytime you have a perfect square times a perfect square times a perfect square, that product is itself a perfect square. The square root of this thing is what we want next. So we're going to end up with 6, the square root of 36, times x squared, which is the square root of x to the fourth, times y, the square root of y squared. Meanwhile, on this side, there's nothing we can do to simplify this, so we end up with just 2x, y, under the radical. So this thing right here is equivalent to this. It's just that we factored out the perfect square and then took the square root of it.